Hey everybody, thanks so much. I was just talking in the back channel about how this format, as much as you can for an online conference, really feels like YVR, single track, chatting with people. Like, it's been really awesome. So I actually submitted this talk to Matt a while ago, but really it's a ploy. It's a lie. It's a bait and switch. I'm actually here to talk to you about how to use threads in Slack, because no one uses threads in the Mac admin Slack. There's this conception that we don't need organization, we don't need the logical benefits. We have a dissidence for order and reason. I've even heard the term no threads, no masters thrown around. So that's what this, I'm just kidding. That's not actually what this talk is about, but I thought I would throw that in there because, you know, I have a little bias of how to use Slack. I've drank the Kool-Aid, as you would say. So I am a CPE at Slack, and I do CPE things at Slack. My name is Lucas. I live in Bellingham, Washington. So I'm about an hour and a half north of Seattle and about an hour-ish from downtown Vancouver. So kind of in the middle there. I moved to Bellingham several years ago and worked with a small private financial firm. And then I got a job with Slack where I relocated to Denver. Lived in Denver for almost a year. And then I was allowed to go full remote with Slack. And we came back to Bellingham just about a month prior to having our first child. So my wife and I are currently in the 2-month phase of our newborn, which is both incredibly awesome and I'm incredibly exhausted. So I just apologize ahead of time. I'm probably not as sharp, and this slide deck didn't get as much cleaning up as I would have liked prior to this. Fun fact, I also haphazardly designed both the Denver Mac admins and the Cascadia Mac admins little Apple logos that you see there. So the stickers floating around for the Cascadia one were, there's actually 2 shades of blue. So if you have a darker shade blue, that's like first generation. But anyways, Nebula, what's it have to do with Mac OS anyways? So that was fun because it rhymed. Cool. So in this session, we're just going to talk about what is Nebula, why would you want to use it, and then how does it really relate to Mac OS? I just want to start this by saying that I didn't have any part of the development. I'm a client platform engineer. Nebula was actually released open source, so it's a Slack HQ Nebula, and this was something that was designed and implemented by our prod security team. So I actually had nothing to do with this. I've got to see it work in real life, but I didn't actually contribute to it. So what it does is it's a mutually authenticated peer-to-peer software-defined network. So a bunch of words about peer-to-peer things. We're going to dig into it. So what's really cool about Nebula is it actually uses certificates to assert everything about a node. So its IP address, its name, and then any group membership is also like contained within the certificate, which is really cool. And then from there, it can be kind of divided up into user groups, which are also tied to the certificate. So it allows for discovery nodes. So it's a true mesh in the fact that there is no defined network. The network itself is virtual, which we'll dig into. And Nebula was created to provide a mechanism of hosts to communicate securely cross-cloud, which is what's really awesome. So when it's a mesh, it's truly a mesh. So you're not really going to be bound by local networks, cloud networks, things like that. So you might be thinking like, oh, so it's a VPN. Well, yes and no. So like I'm going to use this in the context of a home lab. So like here's an example home lab. So in a traditional VPN, you would have to have a VPN software running, and you're effectively getting into a network, where as something like a mesh, it's like, okay, now we can connect to any of our devices from any of our devices directly, which is awesome. And I just want to continue in saying that, admittedly, like this is probably more DevOpsy than it is Mac. In fact, like it's mostly DevOpsy. I just thought it was really awesome, and a lot of folks in this community would really dig on what this project's doing. So I hope we're cool with that. So let's break down what we were talking about. So mutually authenticated peer-to-peer software-defined network. So let's take it down even further. So mutual authentication. So peer-to-peer mutual authentication, which is a cert-based authentication mechanism. So I'm not going to break this down. I don't have time for this, but there's loads of really good docs out there. I've linked to some like a blog post in the docs on GitHub, which I've also posted into the Discord channel. You can check out more there. So I'm not going to dig into this, but this is true. This is how it works. And then the second part of that is the software-defined network. So this is great because it's network agnostic. So you can literally pick a block of network IP addresses that are true to this software-defined network and then start going to town. So you could pick whatever size block you wanted depending on how big of a network you wanted to run here. So the Nebula interface itself, when the binary is running on a client, has its own port, network, and IP that it works through, which is so awesome. So let's look at the pieces and what you need to kind of get this going. So for sake of simplicity, we're just going to look at like a home lab example, maybe a DevOpsy example, if you will, and kind of a minimal, like how many pieces do you need to really see what it can do? So there's kind of three main pieces. So lighthouses, nodes, those are kind of the two players in the game. Nodes can be lighthouses, lighthouses can be nodes. The only thing that makes a lighthouse versus a node is the lighthouse is used to find each other. A lighthouse is our nodes on the network that the IP should not change. So this is your publicly available, public-facing point of access to allow your nodes to find each other on this software-defined network. So running a lighthouse requires very few resources. I think I run mine on a $5 a month DigitalOcean instance. So like super, like one gig of RAM, like super low. And then clients are anything you want to use to connect through this. And then you need a CA. Oh, the CA, woof. Well, you know, we'll get into it because if you are having a cert-based communication, you need a CA to sign your certs, but we'll talk a little bit more about that later. So here's kind of a really simple, you know, illustration of what this could look like. So you have a lighthouse out there, and that basically has a client that goes to the lighthouse and says, okay, here I am. Where are you? Here I am. Where's everybody else? And the lighthouse knows that, oh, this client's over here. So where do I go to get to him? And then from there, once that communication has been established, then that allows the nodes to talk to each other. So at a very, very simplistic high level, this is kind of what it looks like. So how does the certificate authority play into that? Well, the certificate authority is actually used to sign everything. So you have a single certificate authority that signs all of the certificates for your nodes in your lighthouse, basically validating the fact that both of these devices or any device can trust one another because it's all signed by the same CA. And that's where the mutual trust comes into. So let's kind of look at this in an assembly piece. So if you were going to do this, say you were going to do this at home and you wanted to have a lighthouse and a node, and then I call what this is management one. So this management Mac is the Mac that I'm doing this from, but is not a part of the network. So it's just some other device that I'm configuring everything on and then shipping it off to the devices. And this is all kind of loosely based on a blog post that I did that are also in the docs that kind of steps you through more granular of how to set this up and like how to get the binaries going and stuff. So basically, you know, management one we use to configure the devices, both Lighthouse one and Node one. But for sake of illustration, management one is actually not a part of the network in this illustration. So we're going to kind of plan everything out because the first good step in any process is a plan. So let's pick our network topography. Cool. 168.100. Sweet. Let's use, for our Lighthouse, we're just going to use a cloud-based VM. We're going to patch it. We're going to apply the firewall rules. We make sure it has a public IP that's static so that we can find it, and then a Nebula IP, and all Nebula IPs are static. And then we want to have a node to connect to that, and that's going to be 100.2. So we have Lighthouse sitting at 100.1, and we have node 1 sitting at 100.2. Again, this is a software-defined network, so we could literally do, again, whatever you want as far as these are concerned, because it's software-defined. So this is kind of our plan. This is what we want to end up with. Notice we don't know what the IP address is for the Lighthouse yet. It hasn't been set up. This is just kind of our outline. So we're going to go ahead and we're going to go get the binaries. So on the GitHub for Nebula, there's a slew of different binaries for all sorts of platforms that you can get. macOS is there, ARMs if you want to do Pis, whatever you want to do. So go get the binaries, and then we're going to use, we're going to look at those binaries, and inside those binaries, there's two things you can do. You have the Nebula binary, which runs the service, actually does all of the communication, and then you have a binary called Nebula cert, which is used to sign and distribute this, sign the certs. So we make a CA, so it's as simple as Nebula cert CA my.org, and then that gives us a CA cert and a CA key. So CA cert, it's just like any other CA cert. That's kind of your thing that we're going to pass around for trust, and then a key, and key is what we're going to use to sign everything. So the key here is the most critical point in the certificate infrastructure for this, because that's kind of the signer of truth. So on Lighthouse, let's create a certificate for a Lighthouse. So we're going to do Nebula cert sign. We're going to call it Lighthouse 1. We're going to give it this IP address. So if you notice, when we're creating the certificate in key for the Lighthouse, we're actually including the information of the node. So its IP address, its name, and then groups, which we'll talk about later, are actually contained within the certificate information of the device. So that's all tied into its identity. And then we're going to do its config. So configurations are all YAML-based for the nodes. They can be done a couple different ways as far as certificates go. But so for a Lighthouse, let's take a look at it as an example. So PKI, so the CA for our Nebula infrastructure, the Lighthouse's cert and the Lighthouse's key, and where you're going to put that. You can also store CA certs and keys within plain text within this YAML as well, using a block inside of YAML. So that's an option, depending on how you're deploying it. Maybe you prefer to use flat files and rotate the flat files. So we're going to set up where to look for it. So static host map. So am I a Lighthouse? Yes, I'm a Lighthouse. And then this is where I live. So the Nebula IP address of 100.1 is bound to this public IP address. And that's where we'll find it on 4242. Listening wide open. We're gonna put the interface as Nebula 1, and then these are actual rules, which we'll get into a little bit more later, about traffic. So we're just going to say basically on the network, on the Nebula network interface for this device, anything can come out, but we're only going to allow pings in. So ICMP in. Sweet. Okay, cool. So we have that, and then we're going to put that down. So then we get the binary from the binaries that we downloaded, and then if you want, depending on the type of device, launch control or launch deconfig or systemd or whatever you want to use, you can create a service to run it automatically. So we have all of our little pieces down here, down at the bottom. We're going to take those, and now we're going to start shipping them off. So we have the Lighthouse cert, Lighthouse key, the config, and the CA. So we're going to ship that off to Etsy Nebula on our Lighthouse instance. We're going to take the binary, make it executable, and we're going to allow it, if you want to set up the service, you set up the service. So yeah, ship it on off, and then that should be good to go. So from there, we can load it, run it, make sure it's configured. The Nebula binary has some built-in linting and things. So if you try to run it and the config's wrong, it'll tell you. Very modern and all of that, so you can keep going with that. And then add any UFW rules or whatever firewall rules you want to use, just to allow 4242. And then we're going to do the same exact thing on node number 1. So same idea, same configuration. We're going to tell it where to look for a Lighthouse. So is it a Lighthouse? No, but the Lighthouse port is this, or IP is this, and then that is already also included in the static host map for the node, so it knows where to look. So earlier on when I said, okay, we need to have definitive place to look for Lighthouses, that gets defined in these configurations, so you know where to look. Again, what port are you listening on, and then your inbound, outbound rules. So same idea, make an execute, move everything to your client. Basically, the node 1 assembly is the same as the Lighthouse assembly. So same kind of pieces, same kind of launching. There you go. The only real difference is the configurations. So if you're just finding us again and you saw the configuration of the Lighthouse, the TLDR is the node configuration. The only difference is the fact that it's not a Lighthouse. So we've got our node and our Lighthouse configured. I use the example of DigitalOcean, but you could use whatever you wanted as far as other nodes or Lighthouses. So say you wanted to run on Linode instead of DigitalOcean, that's your prerogative. And then you start adding more devices into this, and it starts to become like a truly mesh network. So as each device is running a binary with a config with different rule sets, you can start to create this internal mesh. So here's like a home lab example of some Pis, some minis, 2 cloud instances, and a mobile NAC. So we're going to get into inbound and outbound rules, which are really just configured very similar to like firewall rules. So everything defaults to deny, and then from there you can specify the port, the protocol, and the host group that can access that node or through this config. This is really awesome because it's plain text configuration. It's right in the YAML. So if you're using a configuration management tool, this is really easy to propagate through a template system. And then groups. So groups are established in the client cert when it's generated. So there's a little bit of kind of foresight needed here to know like what groups you want to have and like what access you want to be tied to said groups. So for example, if I wanted to make a node named laptop at 100.3 and I want to give it groups, laptop, home, and SSH. So then what I can do is on any other nodes, I can say inbound rule, the port number, and then what groups or host is applied to. I did a kind of a faux pas here and I made the name of the device a group name. So it's like laptop and then groups, laptop, and home. So maybe you would say like MacBook Pro, whatever, be a little bit more definitive here. But the idea is that you can define inbound and outbound rules on nodes based on different hosts that you have or different groups that you have. So for here, the SSH group we'll get into later, you can assume that if a device belongs to SSH group and then that rule is enabled on any other nodes, then that device would have access to SSH through that. So putting my node 1 into the SSH group and then allowing that SSH group SSH on all the other nodes basically says from node 1, I can SSH into all of the HomeNet nodes, but they can't come back to my node over SSH. So it's a unidirectional kind of limitation on that. Another example is how I do like monitoring. So for example, I have different ports assigned to configs based on the different things that should be scraping them. So like I have a Pi that's running Prometheus that's scraping different nodes. So it's scraping all the cloud nodes or anything that's hosting and bringing that back. But I only actually expose the Grafana interface from a laptop node. So like you couldn't get to the laptop or the Grafana port number on any other node that doesn't belong to like the Grafana group. So from there, you can actually start to see like different stats and stuff purely available over just this software-defined network. So here's a net. So this is a Grafana. This is a Grafana dashboard scraping Prometheus, scraping net data via Prometheus. So if you don't know about any of those tools or some of them, those are all linked. I really love all of those open source projects as well. But so this is actually net data running on my node in the cloud that acts as my Lighthouse. And this is that like lowest tier DigitalOcean instance, and it's like barely hitting any of the CPU and the RAM pressure is so low. So just a kind of an illustration of like, I'm running probably like 12 or so devices on this network, and it's like super minimal impact. I never go over the usage for that node month to month. So, and then, Prometheus is another example of how I can actually, inside the Nebula YAML file, you can actually enable Prometheus metrics, and I think it has graphite metrics as well. So you can actually see your stats about the Nebula network itself. So I'm actually using Prometheus to scrape the metrics endpoint on on my Lighthouse node. So from here, you can start to see like packet loss and different things like that. It's all available through there. And that's a pretty default, like, I think I found a template and just kind of spun it up. So from there, then you can start going the other way too. So like set up, so FileBeats, for example, is running on the cloud instances and pulling off security logs and things like that. And that's shipping logs back to a little elk stack over, again, another Nebula port. So lots of different ways that you can like slice and dice this. Probably not doing a super great job of illustrating just how flexible it is, but when you start to see how the pieces can fit together with the groups and the assignments and like the configs, then you can start to kind of expand out to like what this could be used for. One thing I didn't touch on that I kind of referenced was SSH. So what's really cool about Nebula is that it actually has SSH built into the Go binary and can run SSH itself. So what this means is that you could effectively turn SSH off by default on the box, have Nebula running, and if Nebula is running and connected to the Nebula virtual network, you can SSH into that box via the Nebula network and have SSH on the box itself completely disabled. So SSH on the Nebula network would be available on a port only available to the Nebula network. And then you can configure your public key strings right within the configs for the node, saying like, okay, here's your authorized keys basically within that. So that's really neat. If you're like overly security conscious and you like just don't want SSH open at all externally, this is effectively open only internal to your Nebula network. So different use cases. So like a VPN. Yeah, okay, sure, yes. So I'm using it like a VPN, like a very slice and dice VPN. But yeah, it doesn't stop there though. So what's awesome is now since it's software defined, it's cloud agnostic. So it's network agnostic basically. So you could have multiple instances in multiple clouds all running this tool and allowing them to communicate to each other aside from any need for any other network tooling. So basically the internet is your network and all that fun stuff we hear. The UDP punching is crazy good, quote unquote, is how I've heard it described. So basically the ability for a client to traverse itself outside the NAT up to a Lighthouse and find its communication is really good. I have never had an issue in coffee shops, multiple public Wi-Fis, anything like that with it being able to make a connection. So yeah, you're effectively on a private mesh network anywhere. And then as an administrator, this is awesome because you can control ports, protocols, everything by configurations. So, that also being the main downside is that configuration is fairly heavy. But if you have a config management tool, then it kind of changes the game with templating and groups and different things that you can use your tools for. Like some of us probably aren't running Chef Puppet or Salt at home. Some of us probably are. So it just kind of depends on how deep into the weeds you want to go. So like my home dev stuff, I set up manually, but like as it would grow, or if you wanted to implement it, there's definitely some heavy lifting to do as far as planning and going from there. So CA implementations, like I said, it's manual. Like Nebula, the project, open source project itself, doesn't have any server-side signing type of it's not a PKI. So like you need to figure out how you're going to get the initial configurations to the client set up, because there's nothing really like, basically it's like, okay, we have the CA key and we'll sign requests. Well, how do we do that? How do we do that in automated fashion? Can we do it via an API? Like that's kind of up to you to choose your own adventure for sure on that. So I defaulted to a spreadsheet because it was just the easiest way I could keep track of my home stuff, and everything is a static IP address on the Nebula network. So I just kind of added another one down the list and off we went. There's iOS, there's an iOS app in development, and then there's an Android app in development. There's a couple different resources that I'll talk about. One of them is there's another Slack for Nebula. It's called Nebula Open Source. That link is in the docs. you can go in there and request access to some of the private betas within the different channels. Can't talk about any of those, but they are there and they're available initially. And then I do believe there are plans to open source that those project codes once they get them to a place for that. So that's great, because if it's Android, then you can run it on some Chromebooks, and then you're kind of extending that. So I put together a little GitHub project. It is basically just a README with some links to the Slack HQ Nebula. It'll link you to like join the Nebula open source Slack if you're interested in learning more. The folks that made it hang out in there, and usually are really great about just answering questions and stuff. I did a link to a blog post on mutual auth, which some of this, if you are not familiar with it or you want to learn more, it's definitely a rabbit hole. And once you go down, it's super interesting, but it's very, very dense. Link to NetData, which was the tool that I mentioned for real-time monitoring of nodes, Prometheus, and then Grafana. Thanks everybody for your time. I appreciate it. I know it's a little not super Mac-y and more DevOpsy, but I will jump into the speaker Q&A channel after this and try to field as many questions as I can. Again, I'm not a proprietor of it. I'm just a community member that likes using it for DevOps type scenarios. So I really appreciate your time, and I will try to answer any questions that I can.